Hey guys, this is Mr. H. Hey, I wanted to go over how to find we're going to be dealing with sequences, arithmetic sequences and geometric sequences. Basically, what we've been doing with linear exponential is almost the same thing with arithmetic and geometric. An arithmetic sequence is nothing more than a linear function. A geometric sequence is nothing more than an exponential function, and I want to show you that. So if you look at this one, I'm going to get this pen. All you're going to do is it's either going to be going up by the same amount, adding, subtracting, and if it is, it's going to be arithmetic, and if it's being multiplied by the same number, it's going to be geometric. So if you look at this, you can see we're going to take a -4. You always take a negative. You always take this one and subtract the previous one. So it's going to be minus a -7. So this is a negative. So when you subtract a negative, it's going to make it a positive. So this is going to be a +3. So the difference between these two is a +3. And then if we do the same thing, if we do a -1 minus a -4, this becomes positive. So this becomes 3. So the common difference, or another term we could use is the slope, is going to be 3. So that's what we would put. So let me clear this. And we put in 3. And it says good answer. All right, so let's do another one. This is a geometric sequence, which basically means it's exponential. So the way that you're going to do this is, let me get the pen again, is basically you're going to take this term and divide it by this one. So it's going to be a -20, 120, divided by a -20. And the negatives are going to be cancel out. So that's going to be basically 120 over 60, or 120 over 20, which is going to be 6. So the common ratio for this would be 6. And you can double check it, a -720 divided by a -120. Again, that will give you a +6. So the common ratio is 6. So if I clear this, put this, and do 6 here, that should be the answer. And that's correct. So let me clear the drawing. I thought I'd done that, but obviously I didn't. So let me clear it and get out of here. Now let's go look at a couple others. So this one is find the common. So here, if we have a sequence is equal to A1, common ratio. Yeah, this is going to be, unless we use that. Let's go and see it. This one. All right, so here we're trying to determine if it's arithmetic or geometric. Arithmetic or geometric, that's what we're trying to do. Now, you can see if I do 20 minus 100, that's going to be a -80. This is not an arithmetic sequence. This is actually a geometric sequence. And the way that we're going to figure it out is, let me get the pen. We're going to go 20 divided by 100. And that's going to be, that simplifies to 1/5. Okay, and then you can do the other one. 4 divided by 20 is also 1/5. 1/5. So I can clear this now. We know the common ratio. This is a geometric sequence. It's exponential, and the common ratio is equal to 1 divided by 5. All right, so now let's go next one. This one also is geometric, because you can see, let me get the pen, that if we do 30 divided by 180, that's going to be 1/6. And if we do 5 divided by 30, it's going to be 1/6. So our answer for this is going to be geometric. And common ratio is equal to 1/6. And then we press enter, and then we have it. I want to see if I can find all right, so this one. Let me get the pen. Let me clear this. So in this case, it's going to be 7 minus 3, which is 4. And then 11 minus 7, which is also 4. So you can see that the common difference, this is an arithmetic or a linear sequence. So we can go here and go, this is a linear or an arithmetic sequence. And the common difference, because we subtracted, is equal to 4. So basically, this is just a continuation of kind of what we did with linear exponential. But these are sequences, and we will talk a little bit more about what makes a sequence. But it's basically the same thing as linear versus exponential. So I'm going to submit this. And that's right. And I'm going to end this and post it.